It's going to be 1, 1, 1. And it's delta T. All of this. So trial 2, make sure you see all this. Trial 2, you're going to have 29.1 minus 25, so that's going to be 4.1 degrees Celsius. Trial 3, that's going to be 2.1 degrees Celsius. And trial 4, that's going to be 4. So, to find the inconsistent data point. So right away, since in the equation, the only thing that in the table, the only thing that's changing between trial 2 and trial 4 is the initial temperature. But they all, trial 2 and trial 4, have the same delta T. Pretty much the same, 4.1 and 4.0. So you can automatically say that these two are consistent. So it comes down to whether trial 1 or trial 3 is the inconsistent data. So in trials 2, going back to trials 2 and 4, this has 0.5 grams, and this has 0.5 grams. And these each have 0.25 grams. So, assuming that the delta T is, for this one, is 4.1, and it's half the grams, you can assume that's half the delta T. So half of that 4.0 or 4.1, that's going to be around 2. So trial 3 has 2 degrees Celsius change. So then you can assume that that's the consistent one, and this is the inconsistent one. So I'm going to restate this, answering the question. The trial 1 has inconsistent data. Make sure you see this. And how we identified this? Because trial 1, because to say this, it's not a linear trend. So all the other ones are a linear trend. It would be if you put it on a graph, it would be this is 0.25. That's not the best way to explain it. But trial 1 doesn't match up. I explained it before how this is, because half of the delta T for trial 2 and 4 is 2 degrees Celsius, and since the grams amount for T1 and 3 are half, trial 1 does not match up. Okay, pretty simple to find that one. So it asks to draw a line through that trial, so let's draw a line through that trial. Moving on. Make sure we got all that. Moving on. So for part C, I'll just show you this real quick. It gives you all this data. Calculate the magnitude of Q, the thermal energy change, when MgO was added to 1 molar hydrochloric acid aqueous. Include your units for your equation. Okay, perfect. So what we're going to do is we're going to use the equation Q is equal to mc delta T. So, what did it ask for a second? So, I didn't read this part. So for parts C and D, use data from one of the 3 trials. So we're going to pick a trial. So let's pick trial 2. Trial 2. So there's trial 2, if you can see that. Okay, so we're going to be using the mc delta T equation. So the mass of, so this is mass Q solution. That's what it's asking for. Or Q, okay. So the mass of the whole entire solution is going to be, it's going to be the volume of the HCl plus the mass of the MgO. So in this part, it tells you right here, assume the density of HCl is 1.0 grams per milliliter. So if we have 100 milliliters and you multiply it by 1 gram per milliliter, you can assume that these will cross out, and this is going to be 100 grams per milliliter. 100 grams of HCl. So you got the 100 grams of HCl plus the mass of MgO, and that's going to be 0.50 grams MgO. So that's going to end up being 100.50 grams. Okay. C is the specific heat, and in the equation, and in this part, it tells you that the specific heat is 4.18 joules per grams times Celsius, right there. And then you're going to multiply it by the delta T. So the delta T for this one, trial 2, it's going to be 29.1 minus 25.0. That's going to be 4.1 degrees Celsius. So your final answer in this is going to end up being in joules, because this is given in joules. So when you multiply it all through, you're going to be getting 100. So I'll show you on my calculator. 100.5 times 4.18 times 4.1. Okay. So you get 1722.369 joules. So finding the limiting reactant, the smallest one is going to be right here. It's going to say it's 1.0 grams per milliliter. So that's going to be 2 sig figs. So you're going to get 1700 joules. Or that could be written as 1.7 kilojoules. See that? Make sure everyone sees that. Okay. So that is the Q solution. So that is your answer for part C. Part D.